Fourth graders, today is Tuesday, November 5th, and we are continuing on in Module 3. We're doing Module 3, Lesson 13. This is actually the last lesson before your mid-module test, which will be on Friday. So tomorrow and Thursday we're going to be doing some review, but on Friday you're going to have not a weekly check-in, but you're going to have a mid-module 3 test, which will test what you learned from Module 3, Lesson 1, all the way to today's lesson, Module 3, Lesson 13. Make sense? Okay, so it's a good chance for you to start reviewing over the next 2 days what you've learned thus far in Module 3 and 2 and 1 as well, right? Because math doesn't start over new every module. And today we're doing kind of more of the same of what we did yesterday. We are taking everything we've learned so far about multiplication, addition, and subtraction, and we're using it to solve word problems that sometimes require more than one step. Why do you think in class we solve problems that have more than one step? Do you think in life every problem is just like, okay, let me do one calculation and now I have the answer? No. You know, right now, some of your classmates, their houses are being remodeled, right? Do you think just one calculation will help you figure out how a new wall should be? Or how much material you need to buy? You have to first figure out the space that you're trying to fill, which will then determine how much material you need, which will then determine how much it costs, right? Which will then determine maybe how long you have to save up for. So do you see how in real life problems add on? There's like one thing leads to another thing, which leads to another thing. Kind of reminds me of what we were talking about in science yesterday with chain reactions. Do you guys see that? So multi-step word problems are kind of like chain reactions because, unfortunately, if you solve one thing wrong, how will that affect the rest of the problems? They'll be wrong too, right? So you got to be super careful, especially when you're solving these multi-step word problems, okay? Your problem of the day actually is an example of a multi-step word problem. It says, a pair of jeans cost $89. A jean jacket costs twice as much. What is the total cost of a jean jacket and 4 pairs of jeans? Okay, so the first thing we have to figure out is what is this question asking us to find? Anushka, what's the question asking us to find?
The question is asking us to find the total amount of a jean jacket and 4 pairs of jeans.
Good. We're trying to figure out how much it would cost to buy one jean jacket and 4 pairs of jeans. What important information do we need in order to figure that out? Swarnima?
One pair of jeans are $89.
One pair of jeans is $89.
And a jean jacket costs $2,500.
4 pairs of jeans and one jean jacket, right? Okay, so now we've read the problem and we have to draw, right? We have to draw. Now, a tape diagram is really good here because it can help us find what we're trying to find. Okay, so we know that a pair of jeans, I'm going to write 1J for jeans, is how much money? $89. Good. Now, JJ is going to be jean jacket, okay? If J, jeans, is 1 bar, that's $89. And I know that the jean jacket costs twice as much. So how can I use a tape diagram to show twice as much? Sanvi? Ah. Yeah, that would be 1 pair of jeans, right? But if I double it like that, this one's 89 and this one's 89. That would be the jean jacket. Do you guys agree? Okay, now here comes the real challenge. How can I draw a tape diagram that shows the total cost, T for total, of 1 jean jacket and 4 pairs of jeans? Go ahead and talk at your table groups. How would you draw that? Good conversations. I heard a lot of you guys saying, okay, this 2 89s together, it makes 1 jean jacket. So there's the 1 jean jacket. Then I need 4 pairs of jeans. So I need 4 of these. 1, 2, 3, 4. So all together, my total cost is how many segments of 89? 6, right? My total cost is 6 total segments of $89. So how might I be able to calculate the total cost? Evan?
89 times 6.
Yeah, we need to make 6 copies of 89 because we have 6 copies of 89 right there. So using the standard algorithm, 6 times 9 is? Everyone?
54.
Thank you. I can record the 4 and regroup the 50 into 5 tens. 6 copies of 8 tens is? 48 tens. Plus 5 tens is?
53 tens.
53 tens. So how much money will it cost altogether? $534. In this question, if we want to draw, we can show that all of the seats in the theater is 3,000 seats. Yes? And so far, there have been 5 sections, 1, 2, 3, 4, 5, of 136 seats each. So there's 136 there, 136 there, 136 there, 136 there, 136 there, and another section of 348 that are done. These ones over here are the ones that are not done. Give me a thumbs up if your tape diagram looked something like this. Awesome. So how can I figure out then how many seats still need to be replaced? I have to first figure out how many seats are done, right? What do you guys notice about this section here? There's 5 sections and they're all 136. So how can I find out how many seats have been replaced in that section? What math equation might I be able to do? Swarnima? Good. Let's go ahead and do that. 5 times 6 ones is 30 ones. Good, so I'm going to put 0 because I'm going to regroup all 30 to become 3 tens. 5 times 3 tens is 15 tens, plus 3 more tens is 18 tens. But I'm only going to record 8 of those tens because 10 of them will be regrouped to become 100. 5 times 100 is? 500. Plus 1 more 100 is?
600.
So does that mean that 680 seats have been replaced?
No.
Yes, but there's more that have also been replaced, right? Because there's also this 348. So I have to take this total. I now know that this part right here is 680, but I have to add 348 to 680. How many ones do I have altogether? 8. How many tens do I have altogether? How many? 12, but I need to regroup 10 of them to become 100. How many hundreds do I have? 10 hundreds, which is 1,000. Good. So how many seats have been replaced already? 1,028. Is that my final answer? No, because if I go back and look at what the question's asking, it says how many more seats do they still need to replace, not how many seats have they replaced. So I need to take the total, 3,000, and I need to subtract the number that is already done to find out how many more need to be replaced. 0 minus 8, of course, is negative 8, and we don't want that, so we have to regroup. If I take one of the thousands, that would become 10 hundreds, but I'm going to take one of those to become 10 tens. I'm going to take one of those to become 10 ones. Now I have 8 ones, but I need to take that away from 10 ones, so that is 2 ones. I have 9 tens, and I take away 2, which is 7 tens. I have 9 hundreds, and I don't take away any, so that is 9 hundreds. I have 2 thousands, I take away 1, 1,000. So the answer is 1,972, but I need a unit. Seats. Good. Okay, so again, this is a multi-step problem. With a quiet answer hand, what was the first step? Sunvi?
The first step that we did was we took away, first we multiplied 136 times 5 because there are 5 sections of 136.
Yeah. Very good. So the first thing we had to do is find out how many seats were in the 5 sections of 136. What was the second step that we had to do? Kaship.
We needed to add 348 to 6.
Yeah, then we had to add this amount to find out how many seats altogether have been replaced. Then we still had one more step. What was the last step we had to do? Garrett?
Wait. We had to subtract 1,038 from 2,000.
Yeah, then we had to subtract in order to find out how many seats still had to be replaced. So as you can see in this one problem, we had to do addition, subtraction, and multiplication, which is the 3 skills we've learned so far how to do. So in one complex problem, you can demonstrate all of your math skills. Does that make sense? Good.